So in my algebra, we did lesson 6 today, and that was all about analyzing graphs. So really, it was no new information about exponential functions, just practicing and of course comparing graphs was I guess the new thing, comparing graphs. But we've been talking about exponential decay for a few days now. Decay functions do what over time? They decrease. How do exponential functions change? Like, what's the pattern? They multiply each time. So exponential decay functions decrease by a factor. So whatever it is that you're multiplying each time is the factor. And it is decay whenever you have your equation and it looks like this in this format. Whenever b is between 0 and 1, then it's decay. When b is greater than 1, then it's growth. So like in the first few lessons where b was 2 or 3, mostly the situations we looked at, so where it was doubling or tripling, that is growing over time. Decay is when you're multiplying by something between 0 and 1. So table 9, tell me a number between 0 and 1. 0.5. Table 1, tell me a number between 0 and 1. 0.67, right? So as long as it's not greater than 1, so I don't want you to get confused and think just because it's a decimal, it's decay. It's only if that decimal is between 0 and 1. Okay, so like if it's 1.5, that's bigger than 1, that's growth. If it's 0.9, that's decay. Now, as far as making the equation, so you got to know what A is in the situation. What does A stand for? Good. I like saying the initial amount because then they can start with A, but it's up to you, however you remember it. B is our what? Common factor. So whatever it is that you're multiplying by, you happen to know it, plug it in for B. If the problem instead says what it's losing, maybe a percentage, maybe like a fraction or something, then that's where I point you to this one, which I've told you before means the same thing. It's just that this R gives you what you are losing. Or growing, like it could be a growth situation, like exponential growth, and it could be the percentage is growing. All right, but we were talking about decay today, so I'll just say losing. It could be plus if it's growth, if it's decaying, it's minus. But like, for example, if I get that B is, let's see, 1.7, then what did it grow by? What percent? What'd you say, Austin? No. What do you say? Okay, now maybe I'm confusing you because I'm going back and forth between growth and decay. So let me break it down in little slightly different ways. Everyone, do I have your attention? So the difference between these two is that B is replaced with this expression. So B can be written as 1 plus or minus R. If my B value is 1.7, would that be plus or minus? If it ended up being bigger than 1, plus, good. What would I have had to add to 1 to make it 1.7? 0.7. So this is growth because it ends up being greater than 1, B, and it grew by 70%. Remember we said R is the rate as a decimal. So the equivalent percentage is 70% if that's the case. Let me give you another one. Say that B ends up being 0.45. Since it's smaller than 1, would it have been 1 plus or 1 minus? Think about it. If my B ends up being 0.45, would it be 1 plus or 1 minus? Good. And what is, like, what do I subtract from 1 to get 0.45? 0.55. So if my B value is 0.45, is that growth or decay? Decay, because it's between 0 and 1. What percentage is it decreasing by? 55% is what it's decreasing by. So it depends what it's asking. If it's saying what percent is it keeping, say 45%. If it says what percent is it losing, you'd say 55%. But B is always, even if it doesn't say in the problem, it's always 1 plus or minus the rate. That's how you can figure out the rate. But anyway, the rest of it was a lot of review, but I just feel like that's like a really cool thing, like to understand that these are the same. Depending on what it's asking, the answer might be 45% or 55%, but you can still figure out both. The practice today is 5.06. I'll make sure it's enabled for everyone. But make sure that one's done today first. And then if you're missing others or low scoring on others, then you can go back and practice. You could also look at your old quiz and like correct it and things like that. Like there's lots of things you could do to improve your grade. Yes. I help others. But number 2 on lesson 6, the medicine is applied to a burn on a patient's arm. The area of the burn in square centimeters decreases exponentially and is shown here. What fraction of the burn remains? Write an equation representing the area of the burn after T weeks and what's the area of the burn after 7 weeks. So luckily, a couple of these are perfectly on the grid lines that I can actually tell you what those coordinates are. It did say it's decreasing exponentially, so I'm going to use this setup, which is our equation for a exponential function. Right? Y equals a times b to the x. So it gives me the coordinate 0, 8, and 1, 6 super clearly. The other ones I'd have to estimate, so I don't really want to use those. But you really only need 2. And one of them is our y-intercept, so that's helpful. That would go in from A, my initial amount. B is what I'm multiplying by each time to get to the next number. So can you easily think of what you need to multiply by 8 to get 6? I would say probably not. So that's why in the lesson we talked about how if it's not easy to figure out what you're multiplying by, take the number and divide it by its previous number. So if I do 6 divided by 8, that is 3/4, I think, which is 0.75, but I'll double check. As you should. So yeah, 0.75 is my common factor. 0.75 or 3/4. You could put 6/8 in Desmos or any other calculator, and it could give you the decimal or fraction if you just press a button, and depending on what you want, it'll give it to you. Since it did mention in the question something about a fraction, I'm going to use the fraction form for now.
Yes.
And this is my equation. So when it comes to these questions, what fraction of the burn area remains? So we've talked about what B is B what we are keeping or what we're losing? It's actually what we're keeping. The 1 plus or minus R that B can sometimes be written as includes what we are losing. So if it ever asks that, then where it comes from. But B itself is what we're keeping. So you would put 3/4 is what remains. Then write an equation representing A area of the burn after T weeks. So I'm going to type it in this way and we'll see what the key accepts. But I would just do 8 parentheses 3/4 close parentheses. I'd use the little caret like the shift 6 T. I'd really pay attention to what variables it wants. That's why I didn't put X because it said to use T weeks. Then it says, what's the area of the burn after 7 weeks? So if weeks is on my x-axis, then I am going to plug it in for the x. And to avoid having to split my screen, I'm just going to use my handheld calculator. So 8 times 3/4 to the 7th power. If you typed it in correctly, and you rounded it correctly to 3 decimal spots, it would be 1.068, according to what my calculator says. You got to round to 3 decimal spots. So the decimal was well, it's really long actually, but when I round to my 3 decimal spots here, you look to the right. Since that number is between 5 and 9, I need to round up 1. Let's see what the key says. Okay, it says I'm completely right. Let's see what other alternate ways you could have written it though. So you could have, sometimes this button they'll use, you can't really see it. This button, the star, they'll use as multiplication. I would avoid that. I think just use a parentheses. What else could it accept? Same exact thing I wrote earlier. It could be just this star for the multiplication without the parentheses. But again, I wouldn't recommend that. And then they have the decimal of it, but they don't have every single variation that you could have possibly done. So if it marked it wrong and you just want me to give you the point back because it's actually right, then I'll give it to you. But otherwise, write it this way to me is the most normal way. All right. Any other questions, Gunnar? Number 4 on lesson 6. Okay. Okay, so a caregiver administers 2 different brands of fever reducers to their toddler and adolescent. Okay, side conversation, stop. The graph shows the fevers measured in degrees Fahrenheit above healthy temperature of 98.6 of each child over the course of 7 hours. The toddler's fever is reduced by 1/5 each hour, while the adolescent's is reduced by 3/20 each hour. Lots of fill in the blanks. So, which child has the higher temperature at the start? The toddler, because it has a higher y-intercept. So for these, if it's like kind of a pain to scroll and like drag, you could just press it, scroll, and then click. So the toddler has a higher temperature of what? What temperature would that be? If my y-axis is degrees above 98.6, and then this y-intercept is 5, what's the temperature? No, that wouldn't make sense. It's 5 more than 98.6, the way that the axis is labeled.
So you're doing 98.6 plus 5, which is 103.6. It'd be really crazy if their temperature was just 5 degrees Fahrenheit. Anyway, meanwhile, blank has a lower temperature of blank. So the adolescent has a lower temperature of, what does that look like? 4.5 maybe? So 98.6 plus 4.5, like 103.1. The closest one is 103. So does that make sense so far? It's kind of like our notes. Um, anyway, which child's fever decreases faster? So you could kind of try to look at it, but this over here, in just in words, is where I'm gonna look because it's more exact. Um, if it's decreasing by 1/5, that equivalent decimal is zero point 0.2. The adolescent, it's decreasing by 3/20ths, so that equivalent decimal is 0.15. And this is what it's losing. Who is losing more? The toddler or the adolescent? What number is higher of what they're losing? The toddler, the one, the 0.2, the 1/5. The toddler is losing more, so his is declining faster. So let's see. The toddler's fever decreases more because they have a decay factor. Now, factor is what we multiply. If we're losing 0.2 and I'm plugging that into my 1 plus or minus r, what's 1 minus 0.2? 0.8, which is 4/5, by the way. Because it's losing 1/5, that means it's keeping 4/5. I've multiplied by 4/5 to get the next number. While the adolescent's fever has a decay factor of, and it said it was losing 0.15. So when I plug that into the 1 plus or minus, it's keeping it's keeping 0.85, which I guess I didn't need to convert it to decimals, but let's see which one equals 0.85. That would be the 17 out of 20. These other ones are too big, like it would be over 1, and we're talking about decay. 17 divided by 20 is 0.85. Good so far? So then using D degrees above a healthy temperature, T hours after administration of the fever reducer, write equations to model both of their fevers. So the toddlers, well, let me just remind you our setup. Because it's telling us what we're losing rather than what we're keeping each time, I'm going to use the setup. And it is decay, so I'm going to put minus. What was my initial amount for the toddler? Good. Because that is their y-intercept. You don't want to use a 103.6, even though that is what it is, because I don't know, they did the axes like kind of weird, but this is my y-intercept, not the 103.6. So, or what should I do? I don't know. What should I do? The options only allow for 5 or 4.5, so we'll go with 5. And then for the toddler, we were losing 0.2. The one that's equivalent to this would be this one. 5 times the 4/5, 0.8 and 4/5 are the same thing. We go here. For the adolescent who started at 4.5, so choosing between these two, and it was losing 0.15, which means it's keeping 0.85. 17 over 20 is equivalent to 0.85. So that's going to be for my adolescent. Let's make sure the key is right, and it is. That was kind of a long one, but it's like our notes. Any questions on that one? Yes. Yes. All right, we might have time for one more, depending on how long it is. Serenity? Okay, question 4, lesson 5. So different practice, lesson 5, number 4. We have to select all statements that are true. And okay, so it's not possible to tell for certain whether or not the amount of chemical is decreasing exponentially. The textbook did say this is correct. Like this is not, it's not possible, but only because none of these others, except for the y-intercept, none of these others are perfectly on the grid line. So you're having to estimate the coordinate, so you can't really tell for sure. You can assume, like I figured out what the factor would be that goes with this graph, but according to the textbook, since it's not labeled, it's not enough information, I guess. So we're gonna go with that. It's not possible. When it was first measured, there was 2,000 milligrams of chemical in the water sample. Looks like it to me. That's my y-intercept. And then after 4 hours, there was 100 milligrams of chemical. I can't really tell, honestly. 4 hours, that could be 100. It might not be. I don't think it is. Because I think I actually figured out the factor and I did the math, but according to this, it's not possible to figure it out. So who knows? The amount of chemical in the water sample is not decreasing exponentially, and the amount of chemical in the water is decreasing exponentially. Well, this first answer contradicts those two other answers. You can only pick one of those three. Either it is or isn't, or you can't tell. And according to the textbook, you can't tell because they're not labeled. So just those two for that one. And I think that's all we have time for. But if you still have like a burning question, you can try to ask me in these next couple minutes. I don't think I'll do it.